Okay, so everyone, today's video we're going to complete the chapter periodic motion by finishing the short questions and numerical part that was remaining. So first of all, we are doing the short questions. I will do 5 of the most important short questions that are asked from this chapter in the examination, and let's start. Short questions. Okay, question number 1 is a simple pendulum is taken to the moon. What happens to its time period? A simple pendulum is taken to the moon. What happens to its time period? So we know that the answer is, we know that, write the language part yourself. I'm gonna just tell the thing. We know that the g in moon, the gravitation in moon, is 6 times less than the g in earth. So t prime becomes 2 pi under root l by g by 6. That will happen, or it will be equal to root 6 times 2 pi into L by g. This will be root 6 times t. Therefore, t increases by root 6. That is what you need to write. That's it. Now we go to question number 2. It says if the length of simple pendulum is increased by 4 times, what happens to its frequency? We again know that time period is equal to 2 pi under root L by z. If the length is increased by 4 times, then t prime will be equal to 2 pi under root L 4L by z. This will be 4, this 2 will come out from the square root, making it 2 into 2 pi L by z. So this will be 2t. So then frequency f prime will be equal to 1 by 2t. This will be equal to 1 by 2, and this will be f. So the frequency will reduce by half. You need to write that. Now another question is, what happens when, question number 3 is, what happens when a simple pendulum is taken to the space? And the answer is, we know that again, for the pendulum, time period is 2 pi under root L by z, and if it is taken to space, the z is 0. So equal to 2 pi under root L by 0. This will be infinity. That means the pendulum won't work. The pendulum won't work. It won't oscillate, and the time period is infinite. So now we are going to question number 4, the second last short question we are doing today. And the question is, a boy playing with question number 4, a boy playing a swing is sitting at its bottom. What happens to the period of the swing if he stands up? What happens to the period of the swing if he stands up. So we know that the time period is given by 2 pi under root L by G. And in this formula, when the boy was sitting, his center of gravity was lower, increasing the effective length. But when he stands up, what happens is the center of gravity shifts upwards, reducing the effective length. So when length is reduced, then the time period is also reduced. So the time period is also reduced. That's the answer. If you do not understand, you can message me or comment in the video. In question number 5, what do we have is a loaded spring is taken to the moon. What happens to its time period? It's the same question, and let's do it then. Loaded spring we know that the formula for the time period of loaded spring is 2 pi under root m by k. We know that. And here there is no g, since every term is constant both in earth and moon. Nothing happens. You need to do that. Also, you can write that G is not involved. If you write this much, you will get 1 marks. Alright, then we are over with this. Now we're going to the numerical portion, but before that I would like to give you a small concept so that you understand what will happen when, let's write a note, in an elevator. In an elevator, if the elevator is moving upward with acceleration a, then what happens is, this is the acceleration, the mass and weight will be downwards, and mass and acceleration will be upwards. The resultant normal reaction will be also upward, and acceleration is also upward. Then these two forces balance mg. You get it? These two forces balance mg, so r plus a will be equal to mg. Or acceleration can be found out by acceleration will be equal to this will go there, then mg minus r. We know that mg is what is wrong? Something is missing, because we need another a as well. Something is missing here. Oh yeah, this is the acceleration, but there is a force that is happening, so we are writing this f, and we are doing ma equal to mg minus r. So this will give us r will be equal to, just let's do it from here. Look at this. This acceleration, the acceleration and the normal reaction balance the weight. So mg will be equal to r plus ma because it is a force, not just acceleration. Now if we take the mg minus ma equal to r, then take m common, g minus a equal to r. So this is the relation, and here you see that this should be this the normal equation for this is ma, but here a is replaced by g minus a. So t, is it visible though? Yeah, okay, t will be equal to 2 pi under root l by g minus, oops, it should be a plus, but I messed up, I think. R plus ma equal to mg. Yeah. Oh, okay, yeah. It can be interpreted like this as well, but I'm going to interpret you in a simpler way. Okay, if the elevator is moving upwards, if it is moving upwards, then what happening is, here is your mg, here is your r, and it is moving upwards, right? So what's happening here is that r minus mg will give ma. Do you understand? Because although this is not in equilibrium, it is moving upward, so the force by which it is moving upward is mass times the acceleration, this acceleration, and that is how it came. So we can find r will be equal to m times g plus a. So from this we can find out that t will be equal to 2 pi under root l by g plus a. If the elevator is moving downwards, now if the elevator is moving downwards, then what happens is, it is moving, the elevator is moving downwards, a normal reaction will always be upwards, and the acceleration is also downwards. Then mg minus r will be equal to a. So if this goes the other side and this comes the other side, then mg ma, by the way, mg minus ma will be equal to r, mg minus a will be equal to r. So t will be 2 pi l by g minus a. We have to understand this much, and after we are done understanding this much, then we can basically move to numericals. Now we are moving to numericals. Okay, so before we move on to the numericals, I think for this chapter I will write the formulas for you all. So there are 11 total formulas here, and we are going to list them all in the side of the page so that it will be visible for us while doing the question number 1. The first formula is t is equal to 2 pi under root l by g, the most used and the most important. Number 2 formula is similar to this, 2 pi under root m by k. And now the third formula is velocity is equal to omega under root r square minus y square. Fourth formula is velocity max is equal to where this one will be equal to 0. So omega r. Fifth formula is acceleration formula, that is omega square y or minus omega square y. And sixth formula is acceleration max, which is minus omega square r or just omega square r. Seventh formula is kinetic energy equal to 1 by 2 mv square, which is equal to 1 by 2 m. Velocity is right here, so this will be how much will this be? M v square, okay, omega square and times r square minus y square. This is the kinetic energy, and now we also have kinetic energy max, which will be equal to 1 by 2 m v max square equal to 1 by 2 m omega square r square. And question number 9, formula number 9, we have potential energy equal to 1 by 2 m omega square r square. Question number formula number 10, we have potential energy max where, oh sorry, it is y, where it is potential max equal to kinetic energy max will be equal to total energy will be equal to 1 by 2 m omega square r square. This can be obtained both from this by replacing y to r and from this by putting y square equal to 0, just like here, just like there. Yeah. And now we have the last formula that is very useful, that is 2 pi f. Let me show you all. 2 pi f equal to 2 pi by t. This much are the formulas. If I show you correctly, these are the formulas. You can see, as you can see. Okay, now we are moving on towards our question number 1, which is very easy question. So we are not doing this question. I'm just gonna give you some hint. The displacement of particle executing SHM is y equal to 20 sine 10 pi. Y is in millimeter and t is in second. Calculate. Okay, let's write the question then. The displacement of particle executing SHM is y equal to 20 pi sine 10 pi t. Y is in mm, y is in mm, t is in seconds. Calculate. First we have amplitude, second we have time period, third we have velocity of particle at t equal to 0. Now to calculate amplitude, I told you very early that for a sinusoidal graph the amplitude will be equal to radius, and if we compare this, what is the formula? Y equal to r sine omega t. If we compare it to that, then we will find out that r equal to 20 pi, which is the answer. Calculate. R is in, yeah, this is mm, this is in mm. Omega will be omega t, so omega will be 10 pi 10 pi radians per second, and after that we have velocity at t equal to 0. Okay, that is 2 pi by t. Okay. So yeah, 2 pi by t. Okay, let me see. Yeah, okay, now this can be written as 2 pi by t, which is 10 pi. We got this and we got this as well, so it will be 5 second, or t will be 1 by 5 seconds. And now we need to find the velocity. Okay, this is the time period, this is the answer, another answer. Now the velocity is given by dy by dt, of course, and we differentiate this equation just like d 20 pi sine 10 pi t by dt, and if you take out all the differentiating things, it will be 20 into 10 pi into this will be cos, right? So 20 into 10 pi into cos 10 pi. T is given at 0, so when t is given 0, we just ignore it, because even if this is 0 or not, it does not really matter. Okay, no, we have t here, so when it is 0, this becomes 1, so 20 into 10 pi into 1, that is 200 pi meter per second. This is, sorry, millimeter per second. This is the answer for the question. Now we quickly move on to the question number 2. There is nothing you cannot understand in this question, and this is very less likely to be asked in your exam, but there is a good possibility though. Okay. Now we are moving to a very important question. This is a very important question. Question number 2. Question number 2 says the amplitude of particle in SHM is 10 centimeter and frequency is 10 hertz. Calculate the maximum value of velocity and acceleration. Maximum value of velocity and acceleration of particle, and velocity and acceleration when displacement is 5 cm. Displacement is 5 cm, and C number we have maximum kinetic energy of particle. The maximum of particle if its mass is 0.2 kg. If its mass is 0.2 kgs. So first of all we need to write whatever is given. Okay, so to write whatever is given, we need to first see what is given. Okay, so first thing that's given is amplitude, that is radius, is 10 centimeter. Just convert it to meter, and the frequency is given, that is 10 hertz. The maximum value of velocity and acceleration, we need to find Vmax, Amax equal to what? So first of all we need to find omega. Omega is 2 pi f, so it is 20 pi radians per second. This is omega. Now since we have omega, we know Vmax is equal to r omega. This will be equal to r omega, so that is 10 into 10 to the power minus 2 into 20 pi. This will be equal to, and we have Amax, that is minus omega square r. So this will be we can just take it plus if you want to, or if you keep minus. Omega squared will be 20 pi whole squared and into 10 into 10 to the power minus 2. So if I put this in calculator real quick, then we have, this will be 0. Wait a minute, no, 0. No, this will be 2 pi. This will be 2 pi meter per second, and this will be 40 pi square. 40 pi square meter per second. You can keep the minus as well. Okay, now the question number B says, we have done this one. Now the B number says, this one's for A number, the velocity and acceleration when displacement is 5 centimeter. So the velocity and acceleration when displacement is 5 centimeter means that displacement means y is 5 centimeter. This is 0.5 into 10 to the power minus 2, that is 0.05. okay, 0.05 meter is the displacement. Now we need to find the values of v equal to what and a equal to what. We know that v is equal to, what is v? V is equal to omega. Let me remember, omega, or we can just look here, omega, wait, I'm not going to look, omega r square minus y square. That was it, right? So omega we found out earlier was 20 pi. So 20 pi times r square. We know that radius is given, and that is 10. So that is 0.1 into y squared. Y is 0.05 squared. r squared as well. So this will be somewhat around let me put in the calculator, 20 pi into under root 0.1 squared into 0. Minus, oh sorry, this is minus 0.05 squared. The answer is about 5.44 meter per second. This is meter per second square, my bad. Similarly, we have A will be equal to what is the formula of A? I don't think I can remember that. A is equal to minus omega square y. Okay, minus omega square y equal to, we have omega is 20 pi minus 20 pi into y is 0.05. This is squared, so that will come up to be 20 pi squared times 0.05. that will be somewhat around 197.39 meter per second square. That is the answer. Now we have done both of these, so we need to go to question number C. The maximum kinetic energy of particle if its mass is 0.2 kgs. So the mass is 0.2 kg. We need to find Ke max. We know that the Ke max is given by, we know that the Ke max is equal to the P max. We need to remember this formula. Is equal to total energy equal to 1 by 2 mr square omega square. You need to know this formula. So 1 by 2 into 0.2 into r squared is 0.1 squared into omega squared is where is omega? 20 pi squared. So that will be around let me put in the calculator. So that should be around 3.9 joules, or you can just write 4 joules. And this is the maximum kinetic energy of the body. Now we are going to do the question number 3rd, which is very similar to question number we did in the earlier short questions. So I'm just going to give some hints, and then we will do question number 4, and we will skip question number 5, I think. And yeah, there are a few more. Oh, there are some more important ones. Okay, yeah, we'll do. Don't worry, chill. Yeah. Okay, now since we have done this much, we are now moving on to the next portion, which is the question number 3. I think the question will fit under here. Yeah. Question number 3. What does the question say? Let me write it down. You will do it yourself. That is your homework, let's assume. Question number 3 is after landing on unfamiliar planet, a space explorer construct a simple pendulum of length 50 centimeter. Of length equal to 50 centimeter. I'm not copying the question because it is not like a deep question. So yeah. So you find that the pendulum takes 136 seconds to complete its rotation, complete its 100 swings. It swings 100 times in how many times? In 36 seconds. Calculate the value of G in this planet. So 136 seconds and the number of swings equal to 100. Calculate the value of G on this planet. So what is this given? If this is T, okay, this is not T. This is not T. What is this is it takes 36 seconds to complete 100 swings. Just give it a time. Let's just say time for your 100 swings. So it says it takes 136 seconds for 100 swings. That is, for 100 swings, time equal to 136 seconds. But for 1 second, for one swing, t equal to 136 by 100 seconds. This is the time period. So now we just put in the formula, t equal to 2 pi under root L by g, and we square both sides. So t square by 2 pi 2 pi L will be equal to 1 by g. And if it goes reciprocal, then what happens is, you can see from here, I'm going up here. If you do reciprocal, g will be equal to 2 pi L by t squared. And if you put all the values, the answer should come around 10.6 meter per second square. This is the answer. If there's any confusion, you can let me know. But yeah, that's a simple question. Now we go to question number 4. The question number 4 said, let me write down the question number 4. The question, write it down. Question number 4. The time period of simple pendulum is 4.2 seconds. If the pendulum is shortened, by 1 meter, the time period will be 3.7 seconds. The time period will be 3.7 seconds. Calculate the original length and calculate the original length of the pendulum and the value of g. So if you go and write up solution, then what have we written? What have the question given us? It has given us time for a simple pendulum is 4.2 seconds. It will be t1, and the pendulum is shortened by 1 meter. So what can we write is L1 equal to, let it be L, right? Let it be L. We need to find that. And T2 is given to us, that is 3.7 seconds. And the length of original length we need to calculate, and L2 is shortened by 1 meter. So L2 will be equal to L1 minus 1. If you get me, then correct. That will be equal to L minus 1. So calculate the original length of pendulum and value of g. G equal to what and L equal to what? So we know that T1 will be equal to 2 pi under root L1 by g. Correct? Correct. That will be equation 1. T2 will be equal to 2 pi under root L2 by g. And L2 is equal to 2 pi under root L2 is L minus 1, or L1 minus 1 simply, by g, equation 2. And if we dividing equation II by I, oh shit, I think we made a mistake, but it's okay. This is smaller, but it's okay, I think. 2t2 by t1 equal to 2 pi under root L1 by g whole upon 2 pi under root L1 minus 1 by g. So what cuts off here is this cuts off, and we can simply find out T1 by T2. T2 by T1 is T2 3.7 by 4.2 will be equal to this will be under root L1 by L1 minus 1. If we square it both sides, then what will we end up with is, wait a minute, I think we messed up somewhere. Look at this, T1, and if we were doing T2 by T1, this would be up. Yep, I made a mistake. Because this one is smaller and this one is larger, so this won't satisfy. So I realized that we made some mistake. You also can realize similarly. So if you square both sides, this will be 3.7 by 4.2 square will be equal to L1 minus 1 by L1, and you can just go and write this as 3.7 squared, let me do the calculator first. 3.7 by 4.2 squared, 0.77. 0.77 equal to, this will be 1 minus 1 by L1. So if we minus 1 from that, then we will have, or minus 0.22 is equal to minus 1 by L1. Got the minuses, and or L1 will be equal to 1 by 0.22, and if we divide 1 by that, we will get 4.46. L1 equal to 4.46 meters. Yes, that is the answer. 4.46 is the answer. Now again we need to find the G. So we put L1 equal to 4.46 in equation. You can put any, I'm choosing 1. So T1 will be equal to 2 pi under root L1 by G. So if you get the G, then it will be G will be equal to 2 pi L1 upon T square. I'm doing it directly. If you think there is some confusion, please tell me, but I think this is the correct thing. And you put 2 pi into 4.46 upon T is given as T. This T is T1, right? Yeah, T1. And 4.2 squared, then G should come somewhere around, let me put this value, 2 pi 4.46 by 4.2 squared. Okay, I think something is error here. Let me see real quick. G is below, right? If G goes the other side by being squared, yeah, 2 pi, it's 2 pi squared. Yeah, if we do 2 pi squared, 2 pi into 2 pi into 9.98, so you can see that is the thing. This is meter per second square. Okay, now we're done with question number 4. So we're moving on to, you can see it once. If you want to save it or screenshot it, you can do it right now. That much is the question number 4. Now we have question number 5. Question number 5. The velocity of a particle executing SHM is 16 cm per second at a distance of 8 cm from the mean position, and 8 cm per second from distance of 12 centimeters from the mean position. Calculate the amplitude of oscillation. Yeah, this is a really important question as well. So I'm going to do this one for you all. So let's go. The velocity of, is it visible though? Okay. The velocity of particle executing SHM is 16 centimeter per second at a distance of 8 centimeter from the mean position, and 8 centimeter per second at a distance of 12 centimeter from the mean position. Calculate the amplitude of oscillation. So to solve this question, we have to first list what's given. Velocity of particle executing SHM, it is 16.6 centimeter at a distance of 8 centimeter from the mean position. So there is a particle that is executing SHM just like this. This is a mean position and it is like this, okay, and these are the extreme positions. Let's imagine there are 2 points just like this, and this point is a distance of 8 centimeter and this point is at a distance of 12 centimeter. Right, this point, this is 12 and this is 8. Then the velocity of particle right here is given to be 16 centimeter per second. At the distance of 8 centimeter, the velocity of particle is given to be 8 centimeter per second right here, and here the velocity of the particle at 12 centimeter away from the mean position is 8 centimeter per second. Here the velocity is 8 centimeter per second, and here it is 16 centimeter per second. We need to find the radius now. We need to find the radius of the thing. So to do this, let me go to the other page. Okay, so first of all we have the velocity for the place at 8 centimeter away, 8 centimeter away from the mean position. Then what will happen? Wait a minute, I'll be back in a minute. Okay, yeah, so the place at 8 centimeter away from the mean position, we have V. Let's write V8. Just write V8. What is the V8 formula? We have omega. Formula is omega under root r square minus y square. Y is 8. Let's write y square. Okay, so V8 is given us to be 16 centimeter per second. So 16 centimeter per second is equal to omega, and r square is not given, and omega y is given, that is 8. Is it all right? 8 squared. Yeah, is it all right? Right. Let's give this equation 1. Again, for the place at 12 centimeter away from the mean position, we have V12 is equal to omega r square minus y square. So V12 is given us 8 is equal to omega r square minus 8 squared, but here is 12 squared. Let me check the values real quick. Okay, the value of 8 centimeter and 12 centimeter, 16 and 8, right? 8 and 12, 16 and 8. Yep, correct. Okay, so now this will be equation 2. So if we divide these, then dividing 1 by 2, what do we get is 16 by 8 is equal to omega r square minus 8 square by omega r square minus 16 is 12 square. So omega gets cancelled off, and this will be 2 equal to the root also get cancelled, and it will be, oh no, it does not, I'm sorry, the root does not get cancelled. It will be r whole root r square minus 8 square by r square minus 12 square. If we squared both sides, then 4 will be equal to r square minus 8 square by r square minus 12 square. So if this goes the other side, 4r square minus 12 square into 4 equal to r square minus 8 square. If the other r comes here, then what happens is 4r square minus r square will be minus 12 square into 4 plus 8 square will be equal to 0, and we have a quadratic equation 3r square minus 12 into 12 into 4 plus 64. 12 into 12 into 4, that is 576 minus 64, that is minus 512. Minus 512 equal to 0, or r square can be divided by 3, right? Oh, it cannot be. Okay, so r square will be equal to how much? Wait a minute. Under root, yeah, r square will be equal to 512 by 3. So this will give us r will be equal to under root 512 by 3. This is somewhere around 13 meters. You can just give this. This is the answer. No, it is centimeters. Yeah, we have used every single value in centimeters, so this one will also be in centimeter. That much is the value of r. So it is the second one is slightly very near to the extreme position. Now we have question number 6, 7, 8 and 9 and 10. We have 4 more questions. We have 5 more questions, so we won't do all of them because they are just similar. And yeah, we are not doing question number 6. It is just similar to the to right now, and we are doing now question number 7. Yeah, we are doing question number 7, which will cover the question number 6 as well. Okay, so oh, no, question number 6 is important. Yeah, question number 6 is important than question number 7. So yeah, we're doing 6, and let's see if we will do 7 or not. That is a future thing. Question number 6, what is happening? A trolley of mass 3 kg is connected by two identical springs, each having force constant 600. Oh man, I have to write all the thing. A trolley of mass 3 kg is connected by two identical springs, each having force constant 600 Newton per meter. The trolley is displaced by 5 centimeter from equilibrium. From equilibrium and then released. Calculate A, the period of oscillation. B, the maximum velocity of trolley. And C, the total energy dissipated. The total energy dissipated as heat when the trolley comes to rest. Okay, look at the question. Screenshot it if you want. That's the question. Look at that. Now we are going to do the solution. But before the solution, you need to remember it this way. If two springs, the question will give either in parallel or in series. The question will give either in parallel or in series. The question is given a figure which is like this. Okay, yeah, this is the figure. The mass is 3 kg. This is the figure given by the question. Okay, now if two springs are in parallel, then K1 plus K2 will be the resultant force constant, force constant, yeah. And if two springs are in series, then 1 by K1 plus 1 by K2 will be equal to K. You remember the resistance and capacitance things, right? In resistance, series would have been like this, but in parallel would have been like this. But you have to remember it like capacitor or capacitor. So K follows the K follows the C. R is different thing. So don't remember R here, remember capacitance. So capacitance works in this way. Similarly, the force constant also works like the capacitance resultant. Then what have the question given? Now let's go to the solution. The question has given that mass is equal to 3 kilograms. The K1 and K2 both are equal, giving 600 Newton per meter square and Newton per meter, my bad. So K will be 600 plus 600 equal to 1200 Newton per meter, and we need to find, what do we need to find? The period of oscillation, the time period. What is the time period? And the maximum velocity of the trolley, and the total energy dissipated as heat when the trolley comes to rest due to damping. It says that the total energy that is dissipated as heat, the full energy when the trolley is coming to rest. That is basically the kinetic energy maximum. The total kinetic energy is being asked in the question, or you can just do that energy max, but we know that energy is equal to kinetic energy is equal to potential energy when it is maxed. So first of all, we're finding the value of time period. Is very easy, that is 2 pi under root m by k, and since we know the mass, the time period will come around 3 by 1200, and this will be 0.31 seconds. Since we have the time period now, we need to calculate the maximum velocity, V max. We know that for a simple harmonic motion, V max will basically be equal to omega r. And we don't have omega, so we can just write 2 pi by t into r. And the question has given us r as look at this. The trolley is displaced by 5 centimeter, that is the r. Because it is displaced by 5 centimeter, and there is no way we are talking about y here. So the whole displacement is just r, the maximum displacement. So it will be 2 pi by 0.31 times r is 5 centimeters, so 0.05. This will exactly be equal to 2 pi upon 0.31 into 0.05. This will be almost equal to 1 meter per second. That is the velocity, maximum velocity. Now we then need to find the kinetic energy. Now Ke max equal to 1 by 2 mv max square. So 1 by 2 into 3 into 0 into 1 squared. So this is basically 3 by 2 joules. Therefore the total heat dissipated as total energy dissipated as heat is 1.5 joules. That's how we do it, and the question is complete. Now we are going to the question number 7, and we are skipping this question number 7 very proudly and loudly because oh no, we cannot skip the question number 7 as well. There is a very key thing we need to remember in question number 7. Okay, yeah. Okay, yeah. We have to do question number 7 as well. Yeah, we are good till now, right? So I'll be back in a moment. Okay, so we have question number 7 right here. The question says the small mass of 0.2 kg is attached to one end of helical spring and produces an extension of 15 millimeters. The mass is now set to vertical oscillation. The mass is now set to vertical oscillation of amplitude 10 millimeters. What is the time period of oscillation? Another is maximum kinetic energy of mass. Another is potential potential energy of the spring when the mass of 15 potential energy mass is 5 millimeter below the center of oscillation. Okay, this question is a great question, and it might also be asked in the questions with similar pattern might also be asked in the entrance examinations. So first of all, the things that are given in this question are, let me write down. The mass is given 0.2 kilograms. The extension produced, which is a new term for this portion right now, that is 15 into 10 to the power 3 meters minus 3 meters. That was given in millimeter. I converted it. The amplitude, which is r, radius, maximum displacement, is 10 millimeters, which is 10 into 10 to the power minus 3 meters. Now what it is asking us is the period of rotation is what, and kinetic energy, period of oscillation is what, and kinetic energy max is what, potential energy at a certain point is what, and also displacement it has given us, I think. Yeah, while the displacement is 5 millimeter, potential while the displacement is 5 into 10 to the power minus 3 meters. Now we need to first find the time period. Time period we have is 2 pi under root m by k, but we have no way of finding out k in this question. There is no idea of how we are going to do k, but we have a relation that is very useful in this type of situation, that is mg, the weight, is equal to ke, extension produced, times what, constant, force constant. The product of these are equal in this question because that is given, and there is no external force. It is like the condition of self-supporting. Yeah, so in that we can put m by k. That means m by k will be equal to E by g. So this can be written as 2 pi under root E by g. That is 2 pi under root E is 15 into 10 to the power minus 3 by g is 10, which on solving will give us 0.24 seconds. Now that we have the time period, we can easily find out the kinetic energy max, which is given by 1 by 2 m omega square r square. So to do 1 by 2 m 2 pi by t whole square times r square equal to 1 by 2. The mass is given 0.2 into 2 pi is 2 pi, and t is 0.24 whole squared into r. Radius is not given, but it is given. Radius is 10 to the power minus 3 meter squared. So this will come around 6.85 into 10 to the power minus 3 joules. That is the answer. Now again, for PE we have the formula of potential energy is 1 by 2 m omega square, r square for maximum but y square for the given y. That is 1 by 2 m into omega is 2 pi by t, that is 0.24, that whole squared, into y is given 5 into 10 to the power minus 3 equal to 1 by 2 into 0.2 into 2 pi by 0.24 whole squared into 5 in 10 to the power minus 3. This will be somewhere around 1.7 into 10 to the power minus 3 joules. That is the potential energy at the given point. That is the 7 number of numerical. You can save it just like that. There is it. Now we are going to the next question number, that is question number 8. The question says the simple pendulum of length 4 meters swings with amplitude 2 meter. Calculate the velocity at its lowest point and the acceleration of the pendulum at the end of its path. So this question is already done, and I don't think I have to do this again. Question number 9 says that the body of mass 2 kg is suspended from a spring and is found to stretch the spring 0.1 meter. What is the force constant and time period? Okay. Question number 9. This is a very fun question and a very short one as well. A body of mass 2 kg, a body of mass 2 kg. I'm not writing everything because this is just what we did earlier. I'm just trying to solve it. Listen to the question. A body of mass 2 kg is suspended from a spring and is found to stretch the spring by 0.1 meter. What is the force constant in the time period? What is K and what is G? Time period is T. So we know that time period is equal to 2 pi under root L by G. Correct? Yep. And this is also equal to T is also equal to 2 pi under root E L by G. Oh no, sorry. It is M by K here. M by K, and instead of M by K it is also equal to E by G. It is right. So first we are using this to find out the value of T. That is, T will be equal to 2 pi under root E will be 0.1 and G will be 10. So this will give us around 2 pi into 0.1 by 10. This will give us 1 by 5 pi seconds. And now we can put the value of T in this equation to find out the value of D, value of force constant. So 1 by 5 pi is equal to 2 pi under root M by K. This gets cancelled and this goes up. So 1 equal to 10 into under root 2 by K. So this will be, the K will be equal to 10 square into 2. This will be 200 Newton per meter. This is the answer. This was a very short and sweet question right here, and I did it just easily. Now this is it for the numericals of this chapter. Okay, wait, there is one more numerical. Okay, no, there is not. There is, that's it for the numericals of this chapter, and the video ends with this. So yeah, look at the numericals if you want to, the last numerical.